Welcome to this video on the topic of vectors. In this video, we're going to have a look at what is a vector, and secondly, how we can model a vector using the geometric representation, as well as the algebraic representation. Firstly, a vector is a quantity that has both a length, also known as a magnitude, and a direction. A vector may be visualized with an arrow, so the geometric way of representing a vector is by drawing an arrow. Now let's have a look at how this works using an example. Consider a plane flies 310 kilometers on a bearing of north 53 degrees toward the east. What we're going to do is firstly, we're going to model this using our Year 10 mathematics of bearings. Then I'm going to show you how we can remove all of the bearings diagram and keep only the vector. So starting off, let's draw the bearing diagram and then we'll change it to a vector. So I'll get my ruler and I will draw a compass. I have the northerly direction and the plane flew in the easterly direction. So the bearing is going to point somewhere between north and east. I'm not too concerned with the accuracy of the direction. There was an angle of 53 degrees and the length was 310 kilometers. So what we have over here is our bearings depiction of this scenario here. We have both a length, 310 degrees, so that's the length of the arrow, and then we have the angle, which is 53 degrees, so it's pointing somewhere like that. If I wanted to get a little bit more detail, I could say that the center of the compass is point O, and the destination where the arrow is pointing to is point A. This is the bearings diagram. Now what I'm going to do is I'm going to remove the bearing and I'm going to only represent it using the vector. So I get the black arrow over here and I paste it over here. And this over here is what we call a vector. So the vector is represented using an arrow. Now this particular vector, it started at location O for origin and it finished at location or point A. If we wanted to represent this vector using the algebraic notation, then this vector might be called vector OA, and we show it's a vector by putting the arrow above it like so. So this is vector OA. If we wanted to talk about the length of vector OA, then we'd say vector OA, and we would put it within the modulus symbol, which is two vertical bars. So this says modulus of vector OA, or in plain English we could just say that this is the length of vector OA, and we know the length of vector OA is 310 kilometers. There are ways in which we can describe the direction of vector OA as well, but we're not going to look at that in today's video because it's outside the scope of what we're doing at the moment. So that's our algebraic, and this is length of vector OA. Okay, so this is the graphical method here. Now suppose we wanted to represent it using algebra. We of course can use this notation here, but there's at least 3 different ways that we're going to look at, so 2 more. There might be more, but again it's outside the scope of this course. So the other ways in which we can do this are using tilde notation, or we can use bold notation. Okay, so arrow notation we've already had a look at, but I'll draw it in again just for consistency's sake. So we're going to have 3 vectors, 1, 2, 3, or a better way to put it is we're going to have 3 of the exact same vectors. Every single vector is O pointing to A. Now the first one we looked at was simply, it's just vector OA. The second way we can do it is using tilde notation, in which case we might say that this vector over here is simply vector A and it's got the tilde symbol underneath it. So the tilde is like a little squiggly wave. The final way to do it is, I typically don't like drawing it because it's a bit hard, so I'll just type it. We have the letter A, and the letter A is emboldened, just like that. So all of these notations represent the exact same thing. So vector O to A, you can do it with the arrow notation. You can do it with just the lowercase a with the tilde accent underneath. Or you can just draw the letter A and bold it. Now each of these have their merits. This way over here we typically use when we're working with points on a Cartesian plane, because it just makes it easier to understand what the vector's representing. So you'll see this when you typically have points on a Cartesian plane. The other way, where we have tilde notation, this is when we're typically trying to solve geometric problems. Similarly, we often convert from the arrow notation into tilde notation when it's just convenient to do algebraic equations containing vectors, because this is long, this is much shorter. And the final one, bold notation, this is what the textbook favors in place of the tilde notation. I use the tilde notation because I find it hard to draw bold, where you might prefer to do it this way, but you just need to know that the textbook will do this. All of these are equivalent, all of them have different merits. So again, Cartesian plane, when we're doing algebraic equations involving vectors. So in summary, what we had to look at in this lesson was, firstly, we looked at what is a vector. We discovered that a vector was a quantity that had both length and the direction. Next, we had a look at how we can represent them, where we discovered that vectors can be represented simply using the arrows. So the arrow goes from where you started at and points in the direction of where you finish. The length of a vector is denoted with the modulus symbol, which is two parallel bars pointing up and down, and you simply write the vector in between. And then finally, the three ways in which we can write these algebraically are using the arrow notation, shown over here, tilde accent, shown over here, or the bold notation, shown over here.